Hello viewers, today I'd like to continue our journey with quadratic equations. We are going to look at solving an equation which is reducible to the quadratic form. So you can call this a miscellaneous equation which can be reduced to the quadratic equation form. Now this is the question. We have to solve for x, find the value of x which satisfies this equation, that is 5 times square root of 26 plus 5 the whole power x plus 5 times square root of 26 minus 5 the whole power x is equal to 26. Well, looking at this, it doesn't look like it's a quadratic equation, right? However, we can look at this particular detail. Of course, we have to solve for real x, meaning x has to be a real number which satisfies this given equation. Now, we notice that square root of 26 plus 5 and square root of 26 minus 5, they are conjugates, which means that if you multiply them, let's say we multiply square root of 26 plus 5 and root 26 minus 5. This is in the form a plus b into a minus b. So that is a squared minus b squared, which is root 26 the whole squared minus 5 squared, which is going to be just 1, because this is 26 minus 25, which is going to be 1. So we could say that root 26 plus 5 the whole power x into root 26 minus 5 the whole power x is equal to 1 power x from this, which would simply be 1, right? For any real number x, 1 power x is going to be 1. Now, on with this knowledge, let us presume that root 26 plus 5 the whole power x as some variable, say y, right? Then, as per this equation, then square root of 26 minus 5 the whole power x would be equal to this. If this were y into this is equal to 1. So this root 26 minus 5 the whole power x would become 1 by y, the reciprocal of y, because the product of these two is 1. So if this were y, this had to be its reciprocal 1 by y. So now we substitute these two in the given equation. That means 5 into y plus 5 into this is 1 by y, this is equal to 26. Now here we see that the given equation, which doesn't look like a quadratic at all, is now converted into a quadratic equation through this transformation. So now we multiply both sides by y, we get 5y squared plus 5 is equal to 26y. We bring this here, which means 5y squared minus 26y plus 5 is equal to 0. Now, let's see if we can factorize this, right? So when we multiply the coefficient of y squared with the constant term, this is plus 5 into this is plus 5, that's plus 25. And the coefficient of y is minus 26, which means that we are looking for two numbers whose product is plus 25 and whose sum is minus 26. Now, this is pretty evident that it's going to be minus 25 and minus 1. So, we could write it this way, that this is 5y squared, right, minus y minus 25y plus 5 is equal to 0. From these two terms, we take y common outside into 5y minus 1, and from these two we take minus 5 common outside, we get times 5y minus 1. So if we factorize this, we would get y minus 5 into 5y minus 1 is equal to 0. Or this means that y is going to be 1 by 5 or 5. Or if we were to express this in exponent form, this would be 5 plus or minus 1 because 5 power 1 is 5 and 5 power minus 1 is 1 by 5. Now let's go back to the definition of y, which is this. That means square root of 26 plus 5 the whole power x is equal to 5 plus or minus 1. Right? So now we want to find x. The bases are different, so we cannot compare. The powers are also different, obviously. So we can't compare this using the normal comparison of indices. So we'd have to take logarithm on both sides. Let's say we take logarithm to the base 5 because here the base is 5. Okay, so let's take logarithm to base 5. So logarithm of root 26 plus 5 the whole power x to the base 5. This would be equal to logarithm of 5 plus or minus 1 to the base 5. Now log of x power n is equal to n times log x. Logarithm of x power n is equal to n times the logarithm of x. So this can be rewritten as plus or minus 1 times log 5 base 5. Of course, log 5 to the base 5 is 1. So this would simply boil down to plus or minus 1 into 1. So it's just going to be plus or minus 1. Now this side can be rewritten as x times logarithm using the same rule that logarithm of x power n is equal to n times the logarithm of x. We could rewrite this as x times logarithm of square root of 26 plus 5 to the base 5. X times this is going to be equal to plus or minus 1, right? Or in other words, x would equal plus or minus 1 divided by logarithm of root 26 plus 5 to the base 5. So this is the solution that we are looking for. And because this is a quadratic equation with real roots, we are getting two roots which satisfy the given equation. That is x is equal to minus 1 divided by logarithm of root 26 plus 5 to the base 5, and the other root being 1 divided by logarithm of root 26 plus 5 to the base 5. Hope you like this problem. Hope you understood this problem. Sync into our website for previous videos and for taking a look at our future videos as well. Please subscribe and post your comments. Thanks for watching.